We've been looking at the structure of the atom and the protons and the neutrons and the electrons and the energy levels and valence electrons and all of those things about atoms that make different atoms different. And that's all reflected in the periodic table. If we understand how the periodic table works, we also understand the structure of the atom and can predict properties of the elements that they make up. So the very first thing to know about the periodic table is that it is organized by atomic number. The periodic table is arranged by increasing atomic number. So at the top left you have hydrogen, which has 1 proton, then you have helium, which has 2, and then it starts over with another row, and we have lithium with 3. And so as we move left to right across the periodic table, we increase protons by 1. And then there's these big gaps in the first couple rows, and that's because of the way the electrons fill. We'll look at that in a little bit. Remember, protons determine the identity of an element, and they're all whole numbers. There's no such thing as partial protons, there's no such thing as partial neutrons, there's no such thing as partial electrons. We've got to have whole pieces to make up our atoms, and none of them are skipped. And in fact, just recently, they named all of the elements 1 through 118. That's all the elements that have been made or discovered. As you go down the periodic table, the atoms become bigger, and that's because as we move across, we're adding protons and electrons, and those electrons are in energy levels. But when we move down the periodic table, we add energy levels. Okay, so added energy levels make atoms bigger. They get a bigger diameter across the whole atom as we go down the periodic table. The number of valence electrons is also apparent in the periodic table. As we go from left to right, the number of valence electrons increases by 1. That's true in the A group. So remember, the first 2 columns are A group elements, then you have the middle 10, and then you have the last 6, and the last 6 are also A group elements. Okay, so A group, A group. As we move from left to right across an A group, the number of valence electrons goes up by 1. So hydrogen has 1 valence electron and 1 proton. Helium has 2 valence electrons and 2 protons. Lithium has 3 protons and 3 electrons, but because lithium's in the second row, it's got a second energy level, and that puts that next electron actually on the outside, which means it's only got 1 valence electron on the outside. So as we're going down, energy levels increase. Now, atoms are stable with 8 valence electrons because that fills the outer energy level, except the first row. The first row only has 2 things in it because the first row only has to fill the first energy level. So I said that there's those big gaps in the first few rows. That's because of the way the energy levels fill. So we put hydrogen over here and helium over here, and then we start a new row because we have to start a new energy level. Atoms in the same group have the same number of valence electrons. That's actually why the periodic table is called periodic. Periodic means repeating, and as we move from left to right across a row, things change, but as we move from one row to another row to another row to another row, things repeat because we start back over with 1 valence electron. We start back over with a very reactive metal. We start back over every row with the same property that we had at the beginning of the first row. So periodic things repeat. Atoms in the same row have changing number of valence electrons, so as we move across the periodic table, we always go from a metal to a non-metal. That's periodic too. So metal to non-metal, metal to non-metal, very reactive, less reactive, very reactive, noble gas. Okay, so as we move across the row, properties change because the number of valence electrons is changing. Now I just mentioned metals and non-metals. The periodic table is broken into 2 halves, and it's not really halves so much, but there's a big side and a little side. And there's a zigzag line that starts over by aluminum and boron and moves down right, down right, down right. And that separates the metals on the left from the non-metals on the right. Now, the actual dividing line itself contains some things called metalloids, and they're halfway in between. But in general, metals are shiny. They're good conductors of electricity, good conductors of heat, and they're malleable, which means when we hit them, they bend. They can be easily shaped, as opposed to non-metals, which tend to be poor conductors and brittle, and many of them are actually gases at room temperature. But the solids that we do have tend to be brittle and poor conductors. Hydrogen is the only thing on the periodic table that's on the left side. that is a gas, not a, it's a nonmetal. So it is on the left side because it's in the first column because it has one valence electron, but it is a nonmetal, not a metal. Now, there are a few special families on the periodic table I want to mention. The alkali metals, that's the column 1 metals, so you got hydrogen at the top. The rest of everything in this column is an alkali metal. And they're special because these are the most reactive elements on the periodic table, the most reactive metals on the periodic table. And if you think about it, it's because we said atoms are stable when they have 8 valence electrons. Well, 8's a magic stable number, right? That's when the outer energy level is full. If I have 1 valence electron, all I have to do is drop it and I can go back to 8. If I have 7 valence electrons, all I have to do is find one and I can get up to 8. So 1 and 7 are very, very, very reactive. 2 and 3, 2 and 6 are fairly reactive. 3 and 5 are going to form bonds, and 4 can share a bunch of electrons out. 8 is stable. The closer you are to 8, the more reactive you are. So the alkali metals, really, really close to 8, they are the most reactive metals. And it turns out the most reactive metal in the column is all the way at the bottom. And if you think about why, it's because the nucleus is here and its outer electron is like 7 energy levels away. It's fairly loosely bonded to that proton in there, right? It's the attraction between electrons and protons that holds atoms together. But there's a whole bunch of electrons that shield this. So this electron's easy to lose, and that means at the very bottom of this column, we have the most reactive metal on the table. Now, the alkaline earth metals are column 2. They have 2 valence electrons, which means they're a little bit less reactive than the alkali metals, but they still form bonds. Now, the halogens, we're jumping all the way across the periodic table to group 7. These are the most reactive nonmetals because they have 7 valence electrons. That puts them really, really close to having 8. They can gain an electron and become stable. And because they're gaining electrons, it's actually the ones at the top of the table that are the most reactive because their electrons are closer to the nucleus, which means it's easier for that nucleus to attract an electron in. The bigger ones have the same shielding problem going on that the big atoms over here had, so they're a little bit less reactive. So fluorine is at the top of the halogens, and it is the most reactive nonmetal. The noble gases are in column 8A. They don't react at all because their outer energy level is full. They have the magic number 8. Of course, helium only has 2, but that does fill an energy level, so they do not react. So here's a look at the periodic table. We can see they go atomic number increases by 1, valence electrons increases by 1. If you pick an element in the A group number, so say tellurium, I know a lot about tellurium just based on its location on the periodic table. I know it has 52 protons and 52 electrons. I know this is column 8, column 7, column 6. It has 6 valence electrons and so 6 electrons in its outer energy level. I know that energy level is energy level 5 because it's in the 5th period. So, and I also know that it's a metalloid. It's got properties between metals and nonmetals because it touches this zigzag line that separates the metals from the nonmetals. So it's probably a semiconductor. It's probably shiny, but it's probably also brittle. So it conducts under some conditions, as opposed to, say, calcium, which is going to be a light silvery metal. It's going to be fairly reactive. It's going to have 2 valence electrons. And it's probably fairly soft as far as metals go. And I know all that because of where it's at on the periodic table.